السلام عليكم ورحمة الله وبركاته.
وعليكم السلام ورحمة الله وبركاته.
وعليكم السلام ورحمة الله.
وعليكم السلام ورحمة الله.
بسم الله الرحمن الرحيم، والصلاة والسلام على رسول الله سيدنا ونبينا محمد وعلى آله وصحبه وسلم. السلام عليكم ورحمة الله وبركاته. First of all, I want to thank everyone for coming to this webinar. I would like to thank the College of Computer Science and Information Systems in Najran University for facilitating this event for students, researchers, and whoever might be interested in technology topics. I want to congratulate Dr. Mohammed Alshehri for completing his PhD. Dr. Mohammed has received his master's degree from the University of Colorado from the US in 2014. Dr. Mohammed has received his PhD degree from the University of Arkansas, Fayetteville from the US in 2021. Dr. Mohammed is specialized in cybersecurity and information security in cloud computing, networking, and Internet of Things. Today, Dr. Mohammed, inshallah, will talk to us about his PhD work, which is titled Securing Fog Federation from Behavior of Frog Nodes. Thank you again, Dr. Mohammed. Thank you, everyone, for coming today. Dr. Mohammed, you can start whenever you are ready.
Thank you. Assalamu alaikum. Good afternoon, everyone. I would like to thank you all for attending this webinar. And in the next 40 minutes, I will present in this webinar, and I will present my doctoral research that was titled as Secure and Fog Federation from Behavior of Frog Nodes. Here is the outline of my presentation. I will give a brief introduction about my research and its motivation, and then I will conclude that with a brief description of the problem that we investigated in this research. Then that will be followed by summary of the contributions that this research added to the research community in this topic. This research was based on 3 approaches I designed to solve the proposed research problem. And finally is the conclusion. And in this research, I have 3 models centering about fog federation protection from rogue fog nodes behaviors. And in this webinar, I will present only about 60 to 65% of my work because of the time, for the sake of the time, because of the time slot was given to me is about 40 minutes. Here is as all of you know, over the past couple of decades, cloud computing has gained a respective reputation because of the huge on-demand services it provides to end users. Cloud computing has great features. For example, scalability, availability, and also cloud computing providers provides cheap services to end users. And all of that helped to meet the huge need for storage and computation resources by end users. Therefore, people don't need for expensive investment in like a cloud infrastructures on site. So end users like prefer like to remotely store and process their data in the cloud. And cloud computing, as same as everything in this life, has like advantages and disadvantages. So cloud computing has some problems, some issues. For example, the time latency between end users request and the cloud response is high. And also there are a lot of like data security and data security gaps there in the cloud. So customers like need a new model to solve the time latency and maintain the data security solutions that like researchers have come with. So in 2012, fog computing was proposed to solve the problem of time latency between cloud and end users devices. So fog computing came with a great features. For example, fog computing like are seen as like small clouds deployed close to the ground to minimize the time between far data center and end devices. And also end users can like can do like computation and processing for their data at the edge of the network. So as you know, end users like outsource their confidential data to fog nodes for processing and then to be sent out to the cloud for more processing and for like permanent storage. But there is like weaknesses coming up with fog computing. These fog nodes are prone to like malicious attacks or maybe technical issues. Fog nodes like provide computing and storage services to end users in the same area. But we need to ask ourselves important question here. What if this fog node like providing this service to like devices in this area goes rogue or like being compromised by malicious criminals? In this case, end users' data, like end user will not be able to like get the same services they used to get from authenticated fog node. And also their data security would be like prone for like to violation. And also, what if like fog node is down for like maintenance or like experiencing outage? In this case, no services would be provided to individuals or organizations like getting advantages from this fog node. So from there, we saw it's important like to propose approaches to keep on fog computing features, to keep on the features fog computing came up with, and maintain the data security of individuals or organizations' data traveling through fog node to the cloud and vice versa. And also, I want to let you know from now, this research only focuses on like fog and cloud levels. We don't consider like the end user, the end devices level here. We searched the literature review and we found no like other like models solve or discuss the issue of rogue fog node in the context of fog computing. Here is the summary of the contributions this research added to the research community. First of all, we investigated the problem in the context of fog computing in regard of like, by studying rogue fog nodes like impact on end users' data security. When I say like data security, I mean by that CIA tried confidentiality and integrity and availability of like end users' data. And also we studied the impact of rogue fog nodes on other legitimate or on other good fog nodes in the system. From there, we designed the 3 novel approaches to solve the problem of like rogue fug nodes by ousting the rogue fug nodes out of the system, okay, and maintaining the features provided by fog computing. Then we protect end users' data security from rogue fug nodes, and in regard of confidentiality, integrity, and availability. And then we analyzed the correctness and the security of our approaches. After that, we did a simulation of each approach only to check its feasibility and its applicability, not for the sake of like efficiency here, because we are focusing here more on security. Here I will give you a brief like background about an important algorithm. It's used a lot in like information security and cryptography. It's called the attribute-based encryption. I will explain it here briefly because I like exploited this algorithm in my research. Attribute-based encryption, like when we use this algorithm, we can encrypt a message to multiple users, okay? And no users can decrypt this message that's encrypted with this algorithm unless like satisfying the attributes like connected or associated with this user's private key. Anyway, this algorithm has two types. One of them called the key policy attribute-based encryption, the other one called the ciphertext policy attribute-based encryption. I exploited the second one here. Let's consider this example here. We have two users here. The first user like attributes are teacher and computer science department. The second user attributes is like teacher and math department. And here we have this file. We want to encrypt it using this access like structure, and we want to encrypt it under this access structure with these attributes. And nobody can decrypt this file unless satisfying these attributes, unless being like teacher and computer science department, or from computer science or the computer science department head himself. As you can see here, the first user can decrypt it, the second one can't. Let's jump to the first approach in my dissertation. The first one, we name it here encryption-based approach. And this is the model of this approach. This approach has like three important entities. We have here like the set of fog computing, set of fog nodes, and we have trusted authority server, and we have cloud service provider. To let you know, I divided the fog nodes here into fog federation. What does the fog federation mean? It's like we have like attributes for these fog nodes, and we like classified these attributes using location and services provided by each fog node to end devices. For example, here we have location Carolina and Atlanta, for example, and we have services maybe in healthcare, maybe in education, maybe in other sectors, just an example here. And then we divided these fog nodes into groups called fog federation, okay? Now, I will go step by step about the functions of each one of these, the functions each one of these entities play in this model. First of all, as you know, we have like 3 levels in computing. We have more than that, but here let's consider cloud level, fog level, and end users level. We have fog levels here, and we have these attributes. We have trusted authority server. We assume this server is fully trusted here in this research, and we have cloud service provider. The trusted authority server is responsible about like setting up the system and about generating the keys and by providing keys update. And also when we discover like or detect a rogue fog node here in this system, this trusted authority server is responsible about like asking the cloud service provider to re-encrypt the data that's stored in the cloud that hasn't been touched by the rogue fug node. And the cloud server provider here, we use it as storage, like for uploading and downloading the ciphertext from it. And suppose this fug node, for example, responsible about encryption and decrypting data. And before that, when we like provide the decryption process, we divide each file into blocks, okay? And then perform encryption process and upload it to the cloud. The cloud maintain a table called like progress list. This progress list is like the cloud has in it like the fug node ID and the file ID this fug node has, and the available blocks of this file available in this fug node down there, and the needed blocks. Like for example, fug node 1 has file 1 only has like block first block, and it doesn't have like the other 3 blocks here. Suppose we have another fug node coming from there and coming from like the same fug federation, wanna like retrieve this block, retrieve this file. It will send like a message to the cloud asking it to retrieve, to get this file down from the cloud. The cloud will check the progress list, and then we'll see like fug node 1 has block 1 of this file. The cloud will send block 2 and block 3 and 4 to the requester, and will let the requester to retrieve this block from the fug node 1 in the same fug federation. And for here we want to like reduce the time latency between fug nodes and the cloud service provider. Now let's jump to the trusted authority server functions. This server is important here, and we assume it's fully trusted, and it has like it has 5 functions. The first function is like it's responsible about setting up the system, and it's like when it sets up the system, like it generates the system public key and system master key, and also it's responsible about creating the universal set of attributes. And the attributes, as you saw before, we have location. We classified the fug nodes in this system into fug federation based on like their location and the services that they provide to end users. And the third function here is fug federation creation and adding a new fug node to like already like the previous fug federation. And it creates a fug federation here, the output of this function, like it creates fug federation list. This list has like a fug federation ID and fug federation public key, the current version of this fug federation public key, and the fug federation attributes. And also it generates fug federation master key, which is private to the trusted authority server. This key, not like the trusted authority server doesn't send it out to the cloud or fug nodes and fug federations down there. And also it's responsible about generating fug federation public key. The next function is like generating fug node private key, that at the beginning trusted authority server, when it adds like a fug node to the fug federation, it generates fug node private key. Like every fug node in the fug federation has different, they share, by the way, they share the same fug federation public key, but each fug node in the fug federation has different fug node private key associated with its with the set of attributes and with its ID. And we are trying here like to minimize the impersonation issue. We don't want like any fug node in the fug federation to impersonate the identity of other fug node in the same fug federation. The fifth like function is the when it comes to hosting rogue fug node, it's the responsibility of the trusted authority server. Let's jump to the fug node functions. Fug nodes, like the first function, it's responsible about data encryption. Okay, when it comes to encrypt a file, we divide the file into like blocks. It divides the file into blocks, then performing like hashing each one of these blocks. After that, we encrypt the plain text and uploading the plain text along with the blocks hashes into the cloud service provider. Okay, the second like function Fug node can perform or do here, like requesting a file from cloud service provider. When the cloud service provider like receives a request from Fug node, like requesting, for example, downloading file X, for example, whatever file, the cloud gonna verify the identity of this Fug node. Okay, and based on that, it will check the progress list. Okay, and the output here gonna be the ciphertext at the whole ciphertext or blocks that's already there, like maybe other Fug nodes in the same Fug federation have like having these blocks with the address of these Fug nodes. Okay, to let the requester to retrieve these blocks from the Fug node in the same Fug federation. Okay, we want to like minimize the time. We do want to like we want to minimize the time between the cloud and the Fug federation. The third function here is the data decryption. Okay, and also when the Fug node, the requester can decrypt the file or the blocks using what? Using its own private key. And also after like performing a decryption process here, it can like check the integrity of the decrypted file. After that, we have private key update. When it works, this function, it works when like, suppose we detect a rogue Fug node in this Fug federation, the trusted authority server will update the Fug federation public key and the Fug federation master key, and it will send the Fug federation public key to the cloud to start re-encrypting like the data over there, and also to send a copy to the legitimate Fug nodes still in the Fug federation to update their private key to a new version. In this case, when the rogue Fug node want to retrieve a data from the cloud, it will not be able to like verify its identity, and it's coming with us soon. Here, the cloud service provider functions, as I said before, it maintains a table called progress list. Okay, and this progress list like is checked by the cloud service provider into upon like receiving a request from authorized Fug nodes in the Fug federation, or when like the trusted authority server asked the cloud to start re-encryption process of a file. Okay, so as I said before here, when the cloud service provider detects a rogue Fug node in the Fug federation, it will update the Fug federation master key and Fug federation public key to a new version, and then it will send the new version only of the Fug federation public key. It doesn't like send out the Fug federation master key, only the Fug federation public key to the cloud service to start re-encryption process. And also the cloud service provider can check the progress list when like it receives a request from legitimate Fug node in the Fug federation. Okay, and as I mentioned before, it will return to the legitimate Fug node like the whole file or only blocks of the file, and the address of the Fug node having like copy of the other blocks in the Fug federation. Here, how to like start or establish trust among Fug nodes in the same Fug federation, or maybe between Fug nodes and the cloud service provider. It's here we have, suppose we have Fug node 1 and Fug node 2, they share the same Fug federation public key, and each one of them has its own Fug node private key. associated with its ID. And suppose this fug node wanna request blocks from this fug node. Suppose the cloud tells this fug node to like get like block 1 and block 2, block 3 from fug node 2. Okay, this fug node gonna come here and send a request to this fug node by like sending its ID, fug node 1, and the file ID and the block that this fug node wants to return from or get from this fug node, from fug node 2. Okay, this request gonna be signed using the fug node 1 private key. And here, when this fug node receives like the request, it will verify this request using what? Using the fug federation public key, the current version. Okay, and if it's verified, it will return the blocks. Otherwise, it will not be verified. Otherwise, it will be reported to the trusted authority server to take action against this fug node 1, I mean here. As every like researcher in computer security, information security, when it comes to create a model, you need like to create a threat models, okay? And you want, in this case, to like secure your system against these threats. Here we have, I have three threat models, and we have rogue fug node, okay? We wanna secure this model against it, and we have man-in-the-middle attack, and we have curious cloud service provider, okay? And in this model, I have designed 11 algorithms, okay, as you see here. And after that, the evaluation process, we follow two methods. First of all, we provided a security analysis. And the security analysis, I mean by that, like securing my system against the threat model, the threats that I show you in the previous slide. Yes, I will show you how did I secure this model against curious cloud service provider and against man-in-the-middle attack and against rogue fug nodes. And also we show the correctness of my algorithms. I omitted this part from here. You can refer to my dissertation online in my Google Scholar if you are interested to read more about the correctness. And the second method, we do like some experiment. We provided like a simulation of our model to show its applicability and feasibility. Okay. First of all, let's consider the security against rogue fug nodes. Suppose trusted authority server like detects a rogue fug node in the fug federation. First of all, what it's gonna do, the trusted authority server will update the fug federation public key and fug federation master key to a new version, and it will remove the rogue fug node from the fug federation list. Okay, and after that, it will send out a copy of the new version of the fug federation public key to the fug nodes still in the fug federation, to the to the fug nodes still in the fug federation, and another copy to the cloud service provider. A cloud service provider gonna start re-encryption process, okay, of the blocks that haven't been touched yet by rogue fug node. And after that, in this case, rogue fug node cannot update its fug node secret key. Okay, so in future, this fug node wanna like authenticate or itself to another fug node or to the cloud service provider, it cannot, because the fug node secret key that it has here is like is not it will not work anymore. Okay, here in this case, rogue fug node cannot access encrypted data anymore. And about the security against the man-in-the-middle attack, the data encryption is as I show you before, it's proceeding with a hash calculation, okay, and then uploaded with the ciphertext to the cloud, okay. In future, other fog node in the same fog federation like retrieves like a block or the file from the cloud service provider, it can check the integrity of this file, okay? And if someone in the middle messed up with the file, it's easy to detect it, okay? And also the adversary needs the correct private key, okay, related to the fog federation public key to perform decryption process to read the message. In this case, the adversary will not be able to put hand on the, or play off or mess up or tamper with the transmitted data in the transit between fog nodes or between fog federation and the cloud. Here, the security against cloud service provider, we don't outsource everything to the cloud, okay? The data outsourced to the cloud service provider. What are these data? It's the encrypted files or encrypted blocks along with its hashes, okay? And also the cloud has only the fog federation public key, okay? It doesn't have the and it has also a list of the legitimate fog nodes in the fog federation. It doesn't have the private keys that could be used to perform decryption process. The decryption keys in this case not outsourced to the cloud, so the cloud cannot perform decryption process. About the encryption, about the experiment design in this for this model, we had synthesis data set with different sizes, and each data set divided into blocks with size of 50 megabyte here. And I will here the time to, as you can see in this graph, the time to retrieve various size from ciphertext from the cloud and from the same fog federation, outperformed the retrieving the same data from the cloud service provider. And this graph shows that our model is feasible and applicable. And also this graph also shows, you can see from here, when the amount of blocks you retrieve from the same fog federation grows up, the time will be also minimized. Here we have some concerns about, now we finished the first model, and we have some concern about this model. Suppose fog node 1 has, for example, has file 1, okay, and this fog node goes rogue or being compromised by malicious attack. In this case, everything this fog node has will be breached, will be in danger of being breached. Okay, what we did here, from here we jump we wanted to minimize the impact, okay, to data in danger from being breached. We wanna when a fog node being attacked, okay, we wanna minimize the data in danger from being breached through this attack. Okay, from here, what did we do? We achieved that by grouping or the fog nodes in the fog federation into subgroups with different levels. Okay, this is the second model, and we named it multi-level approach. This is the model. This is our approach model. Okay, our approach structure. And this approach has we have a trusted fog node here, and this trusted fog node has its every one of these entities has its functions. I'm coming to that in the next couple slides. And we have fog nodes in the same fog federation. As I said, we divided them into subgroups. Okay, and we have trusted authority server also. We have cloud service provider. And let me give you this example here to make this idea more clear to you guys. And let's consider we have 5 fog nodes here. Okay, and this the fog nodes located, okay, in the outermost subgroup can access the data encrypted to fug nodes located in the inner subgroups. Okay, and if fug node 1 or fug node 2 goes, fug node 1 or fug node 2 goes rogue, one of them goes rogue, list data would be breached. Only the data that are marked with X. Okay, suppose we put like here before we it's the responsibility of the trusted authority server to split the files into blocks depending on data sensitivity. Okay, for example, here X, what does X mean? Is it means less sensitive data. Okay, we store less sensitive data here on X, and mid sensitive data it goes here in Y, and max sensitive data it goes here in Z. Okay, if attack happens here, this data would be breached, or here. Okay, and as before, the cloud maintains a local progress list of encrypted files. Okay, of each fug node. Excuse me. This encrypted files tracking table allows a fug node to retrieve encrypted blocks or file from the same fug federation subgroup. Okay, not retrieving the data from the cloud when the cloud updated and up to date available in another fug node in the same fug federation subgroup. Here, suppose we have here fug node 2. Fug node 2 located in the second level, and it has access to data labeled with X and Y. Okay, and this fug node wants to retrieve data like marked with X. Okay, it wants to retrieve encrypted file 1. Okay, this block of this file. Okay, it will send a message to the cloud. The cloud will check this encrypted files tracking table. Okay, and as you can see here, fug node 1, which located in the innermost subgroup, okay, has this file updated in its database. Okay, and this fug node 2 can retrieve this file. The cloud will tell the fug node to retrieve this block from fug node 1. Okay. Here, another like example here. Suppose fug node 1 goes rogue. Okay, only the data that are marked with X would be breached. Here, let's jump to the trusted fug node functions. Okay, the responsibility of the trusted fug node functions and why we brought a trusted fug node here. It's responsibility to divide the files to be encrypted into blocks. Okay, and encrypt these blocks with the corresponding fug federation attributes. For example, the innermost fug federation subgroup here attribute is X. It encrypts this block with X, and here with X and Y, here with X and Y and Z, because the maximum private data stored here in this block, and then upload that to the cloud. Okay, and the cloud will update the file tracking table that is stored in it. The cloud service provider function here, as I said before, it maintains a file tracking encrypted data tracking table. Okay, and this table is checked upon receiving a request from authorized fug nodes and fug federation subgroup, or from a trusted authority server asking the cloud to start re-encryption process. Okay. When it comes to re-encryption process, suppose trusted and it's coming. Here, yes. Suppose here I mentioned that before. When the trusted authority server asks the cloud how to re-encrypt the data, to encrypt data or blocks or whatever, or file, it will update upon like discovering or detecting malicious fug node and subgroup. It will update.
Talk to you, Dr. Mohammed. We still have only probably 2 minutes, and then if you could just wrap up your presentation. Thank you so much.
Okay. And it will update the Fug Federation subgroup master key and Fug Federation subgroup public key and Fug Federation master key, Fug Federation public key to new versions, and then sending Fug Federation subgroup public key and Fug Federation public key to the cloud service provider to start re-encryption process. And also when the fug node want to retrieve data or blocks from the cloud service provider, it will sign the request using its fug node secret key. And I want to do more explanation here to make everything like clear to you guys, and I'm trying to do that. And I will go fast now. And the fug node function, they are responsible about block encryption, and also they are can request file from cloud service provider, okay? And they can check the integrity of the blocks, the retrieved block, and also can decrypt the file. And also they can update their private key in case of detecting malicious or rogue fug nodes in the Fug Federation. Here we have algorithms that we designed in this model. And also regarding the evaluation part, we followed the same methods we followed in the first approach. Okay, here the security analysis. This model is this model is secure against rogue fug node, and also is secure against man-in-the-middle attack, and also is secure against the curious cloud service provider. Okay, and from here we have some concerns in this model. Okay, how to enable? We asked ourselves some questions. The first question: how to enable the fug nodes in the same Fug Federation to track the encrypted data inside the Fug Federation, and how to prevent other fug nodes in the same Fug Federation from falsifying the tracking information. From here, from here we proposed the third model, and we named it blockchain encryption-based approach, and we got advantage from Ethereum smart contract as intermediary among fug nodes belonging in the same Fug Federation. And we constructed each Fug Federation as a private blockchain, as each fug node member can do authorization process in a distributed manner using something called smart contract. Okay, and these are the publications that I published from this dissertation. I have published 3 conferences here, and I have 2 journals from this work. They are under review for now. And thank you so much. And it's a great my pleasure having you here all.
Thank you so much, Dr. Mohammed. We all, I'm very sure, enjoyed your talk, and it's very, very informative. And I really appreciate the way you're trying to explain everything, your illustrative figures and everything that you did. Thank you so much for that.
Yeah, thank you so much.
You're welcome, Dr. Mohammed. Now we will open some questions from the audience. I'm very sure some people here are specialized in cybersecurity and information security.
Yes, I'm open to any question or any comments, suggestions. Yes.
Yeah. So anyone who wants to start? Any question, please? So I'll start just one question, and then we can maybe some people are still preparing their questions.
Okay.
You mentioned in the beginning, in the first slides, that you didn't really consider the efficiency of the algorithms. Was that a reason for this, or maybe is this something you could consider in the future?
Yes, it's part of my future. I'm like focusing on that in my future research. Okay, but for here, I agreed with my doctoral committees to focus on like securing these models. And regarding the efficiency and the fog node, why did the fog node like come? It came with like great features to minimize the time latency, okay, between the cloud and the end users, okay. And I run the simulation to see are my models gonna be applicable and feasible in future? And I didn't consider actually like efficiency, because out there in the literature, no works like I could use as like baseline to like to compare my work against. Thank you for your question. Yes.
Thank you, Dr. Mohammed. I know that you mentioned the fog computing has been started since I think 2012.
Yes.
Yes. So I really think that what you did is really great. So thank you for that. We have a question from, I think, Hala Al-Harthi. She's asking, what does a fog node use for? Is it like distributed cloud?
Yes, it's Cisco proposed fog computing in 2012 as small clouds deployed close to the end users. Okay, and the fog nodes like can be used to like perform data analysis and okay, and then send in the data to the cloud. And also some of the applications of the fog node, if you are interested to read more about it, and actually it's interesting topic, you can read about like connected vehicles and smart cities. Yes, you will find a lot of applications for fog computing.
That's great, Dr. Mohammed. I was going to ask the same question about the real implications, but you said you talked about some of the self-driving cars and smartphones and some of the IoT implementation for that. Okay, we have another one who wants to ask question. Dr. Abdul Majid, go ahead, please.
Thank you, Dr. Mohammed. It's interesting topic and presentation. So one of the solutions your research is presenting is to secure the sensitive information in the fog using an encryption-based approach. As far as I know, there are other attack models that could compromise the fog, such as denial of service attack. I'm just curious if you thought about solving these kinds of attack in your research.
Sorry, Abdul Majid, Dr. Abdul Majid, thank you for your great question. What's the name of the attack? Could you say it again?
Denial of service attack.
Denial of service. Yes. We didn't consider it. Yeah. Yes, we didn't. Yeah. A lot of attacks out there on fog computing. A lot. But we didn't consider it. Thank you.
Thank you.
Thank you, Dr. Abdul Majid. Thank you, Dr. Mohammed.
Any
other question, please? We still have time, so
Assalamu alaikum.
Alaikum assalam.
Thank you for your informative presentation. I have noticed that one of your application is about blockchain. As we know, blockchain is the best thing when it comes to cryptocurrency. Yes, but one of the concerns is it is power consumption. So my question is not so related to your presentation, but actually I am wondering about the future of cryptocurrency.
Oh, about cryptocurrency.
Will it take over?
You are asking me about Bitcoin and cryptocurrency. Actually, I have no knowledge about cryptocurrency at all, but blockchain can be used, can be applied in different sectors. Okay, and can be applied in healthcare, can be applied in education, everywhere. I have read a lot of researches about that, and I just You want me explain to you why did I like exploit blockchain or what?
Yes, you have
If you
published a
ask me-
paper in that topic.
Yes. Because you know, in my first two models, we have centralization. Okay. So in the third model, we want to get rid from the centralization. We want to like the fog nodes in the same fog federation to interact with each other, okay, without a trusted third party. Okay, and this is the main reason we have exploited blockchain. And if you are interested to know more about it, I can discuss that with you.
Okay, got you. Jazakallah khair. Thank you very much.
What's your name, please?
I am Dr. Mohammed Alshehri.
Welcome,
Yes,
Dr.
we'll meet tomorrow, inshallah.
Inshallah.
One of our faculty members in the college. Thank you so much, Dr. Majdoub. Any other question, please?
Yes, thank you so much, Dr. Mohammed, for the very nice presentation. My question is about the malicious fog node verification. After the malicious fog node is identified, according to your talk, the trusted authority will reissue new keys, right?
Yes, Dr. Sultan.
Send them back to the trusted or legitimate.
Yes.
Fog nodes only. How to protect the blocks that haven't been re-encrypted by the cloud? For example, suppose we have 100 outsourced blocks and
Yes.
Suppose the cloud is in the processing of the encryption and is now encrypting the block number 10.
Yes.
So we still have 90 blocks ready for re-encryption. Can the malicious node get block number 50, for example? It's still be encrypted using the previous key, right?
No, Dr. Sultan. First of all, I would like to thank you for your great question, and it's interesting topic. We can do more work there in future. But here, as you see here, Dr. Sultan, let me show you. Just a second, please. Okay. Yes. We have the trusted authority server here, okay? When it comes to OST rogue fog nodes, the trusted authority server, I'm talking here in the first model, Dr. Sultan, we have the fog federation master key, fog federation public key, and the fog federation list of fog nodes, okay? When we detect like a rogue fog node in the system, immediately the trusted authority server will update these two keys, okay, to new versions here, okay? Then it will send the fog federation public key to what? It will send it to the fog nodes in the same fog federation to update, like here, to update their private, their private keys to a new version of it, okay? And also to the cloud to start re-encryption process here. If you can, I will show it to you here. Okay, the cloud will start re-encryption process. Okay, in future, suppose fog node 1 here is malicious, is rogue. Suppose it's rogue. Okay, if in future this fog node wanna like retrieve data from the cloud or from another fog node in the same fog federation, it needs to sign the request using what? Using its own private key, the correct version. Okay, but it's not in the fog federation list anymore. Okay, and it doesn't have a copy of the updated version of the fog federation public key. So it's a private key not updated. Okay, in this case, when the other fog node or the cloud receives the request and perform a verification process here, it will not match, and they will consider it like rogue or malicious fog node.
So Dr. Mohammed, every request will be signed by the private key.
Yes.
Each fog node.
Yes, the current version, the correct version, and it has to be the correct version. Thank you for your informative question.
Assalamu alaikum.
Alaikum
Alaikum
salam.
assalam.
Thank you very much, brother, for your nice presentation, and I will believe it will open more questions and the great research in the future. I have
Yes.
just two quick questions. Number one, have you considered also tempering in your fog and algorithm? And after this question, I would like to know that what journals exactly you have targeted for your publications. Thank you so much.
Dr. Asadullah, thank you for your great question. I understood the first question, but the second one I didn't. Could you say it again, please?
I said the second question, I just want to see the last slides that you have published the one journal publication and the second is under review. So what is the name of those journals? That is it.
They are IEEE access. Yes.
Great selection. And thank you so much. And let's, I'll wait for the first answer. Thank you so much.
Thank you, Dr. Asadullah. Yes, this research actually is interesting, and I still have a lot of open holes here. We can like address it in future, and you are welcome to join me if you would like in future. And regarding the first question, you're talking about tampering. I think you are talking about tampering. Yes, I mentioned that.
Yes, I'm talking about tampering.
Yes, blockchain is tampering proof by its nature regarding the third model. But the previous two models, I like before I do encryption for the file, the fog node like divides the file into blocks, okay, and then hash each block, and then perform the encryption process. After that, uploading that to the cloud, okay. If we have someone like malicious criminals or whatsoever in the middle, like tamper with the data, when we check after like performing like decryption process and check the plain text against the hash that we had, we already have, if they don't match, we consider it like we consider it bad. Thank you.
Thank you so much, brother. Thank you.
Thank you, brother. Thank you.
Thank you, Dr. Mohammed. Thank you, Dr. Asad. Thank you, everyone. Any other question, please? We know we don't want this to be another PhD defense, but it's very interesting topic.
No, Dr. Yusuf, I'm enjoying that, and I'm happy to.
So we still have maybe 2 minutes, and then we can.
I have a question, Dr. Mohammed.
Yes, Dr.
Yes,
Can your second model be generalized to be applicable in different environments? I think like other than healthcare, like education, businesses.
Yes, Dr. Sultan. Yes, and you put your hand like in one of my future my future paper. Yes, we can generalize it to education. We can generalize it in hospitals. Yes.
Sounds good.
And especially like nowadays in Saudi Arabia, we are like experiencing a great digital transformation. And I think this model will do something good there. Yes.
Yeah.
Thank you, Dr.
Thank you so
Sultan.
much.
Thank you. Appreciate it.
Thank you, sir, Dr. Mohammed. A very interesting topic. I can congratulate you again for your PhD. I think it's a very interesting topic, and everyone was enjoying this, and very engaging actually research. So Dr. Mohammed Hamadi wants to say something.
Yes, please, Dr. Yusuf. I just want to thank Dr. Mohammed Alshehri for this nice presentation today. And I would like to say, congratulations, Dr. Mohammed, for your PhD achievements. We are so proud of you for your achievement, and we are waiting and happy to see you, inshallah, in the college, and to see your effort, inshallah, in the research direction and in the academic, in your department and in the college in general. And inshallah, see you soon, Dr. Mohammed. I just want to congratulations and your PhD achievement, and inshallah see you soon بإذن
Thank you, Dr. Mohammed, and I'm happy to hear that, and also I'm excited to work with you all guys. What I'm not happy about today, I couldn't finish everything. But
no, that's right.
yeah.
That's right.
No, you have more, يعني inshallah
Yeah,
to discuss with your colleagues and your mates, inshallah, in the college.
Thank you, Dr. Mohammed. Thank you, Dr. Yusuf. I appreciate that.
And by the way, for anyone who is still interested to watch this webinar again, this video will be inshallah uploaded in our college channel on YouTube. So everyone is welcome to watch it again if they are really interested, as someone is asking about it. Anyway, we will have another talk about security issue, inshallah, tomorrow with Dr. Abdul Wahab Al-Azib. Stay tuned, inshallah, tomorrow, 11 in the morning. We'll, inshallah, see you tomorrow. Thank you so much, Dr. Mohammed Alshehri. Very great talk. Thank you, everyone, for coming. Wish you have a very good day.